Hello my dear viewers and also my dear students. So I welcome you to this particular mathematics tutorial. So we are going to do this question which says solve for x using matrix method. So we are going to use matrix method to solve for the value of x and also the value of y. And we are going to use matrix method. So one of the things I want you to notice is how are we going to write the simultaneous equation in a matrix form. And after that, we also determine the matrix of the coefficient matrix. We find the inverse. We pre-multiply the matrix equation by the inverse on both sides. And then we proceed. So those are the prerequisite knowledge you require, and also on how to multiply a matrix. So we are going to first write the simultaneous equation in matrix form, and in that case we have to consider the coefficient matrix. Then we multiply by the variable matrix to get the constant matrix. So for our case, we have the first equation and the second equation. So coefficient matrix we get, so x, y, those are the variables, and then we have the coefficient of x, coefficient of y, and we get the coefficient matrix. And then for the constant matrix, we find the constant value. So remember this equation can be written as ax plus by is equals to c. So for our case, a and b are the coefficient, x and y are the variables, and c is a constant value. Therefore, let us write the coefficient matrix. For the first equation, we have minus 1, that is the coefficient of x. Then coefficient of y is 6. Coefficient of x is minus 2, that's for the second equation. And coefficient of y is 7. So that is the coefficient matrix. Then the variable matrix, we write in that order. We start with x, then y will be equal to the constant matrix, that is 13, 11. Remember to write them in a matrix form, row and column. After that, we find the determinant of the coefficient matrix. And to get determinant of the coefficient matrix, we multiply the elements in the main diagonal, minus 1 times 7, which is minus 7. Then subtract the product of the element in the other diagonal, minus 2 times 6, that is minus 12. So minus 12, that's what we require. Therefore, we shall end up getting minus 7 plus 12, which is 5. So that is the determinant. Therefore, to get the inverse of the coefficient matrix, it is 1 over the determinant. The other thing we are going to do, we interchange the elements in the main diagonal. So we shall have 7 minus 1. Then the other diagonal, we reverse the sign. So 2 will be positive 2, 6 will be negative 6. In our case, now this is 1 over 5. The determinant is 5. So 7 minus 6, 2 minus 1. So that is the inverse of the matrix. After that, now we are going to pre-multiply the matrix equation by inverse on both sides. So this is our matrix equation. So we pre-multiply by inverse on both sides, left side and the right hand side. So if we are going to multiply, we shall have, let me start with the inverse, 1 over 5 to bracket 7 minus 6, 2 minus 1, then we multiply by the now matrix equation, minus 1, 6, minus 2, 7, then multiplied by x, y will be equal to, again on the right hand side we pre-multiply by the inverse matrix, 1 over 5 multiplied by 7 minus 6, 2 minus 1, then multiply by the constant matrix, 13, 11. Let us move on. So allow me just to leave the fraction the way it is, then I multiply this matrix and this one, so I'll have 1 over 5. So you know the steps on how to multiply matrices. So the first one is 2 by 2 and 2 by 2. So we shall end up getting a 2 by 2 matrix. So 7 times minus 1, that is minus 7, then plus minus 6 times minus 2, that is plus 12. Then to get the other element in the first row, second column, 7 times 6, 42, then plus 6 times 7 minus 42. The other one is 2 times minus 1, that is minus 2, plus minus 1 times minus 2, that will be plus 2. The other element will be second row times second column, so 2 times 6, that is 12, then plus minus 1 times 5, so times 7 I mean, that will be minus 7. Then we have xy equal to 1 over 5, so 7 times 13, that will be 91, plus minus 6 times 11, so that will be minus 66. Then 2 times 13, that is 26, plus minus 1 times 11 minus 11. So we move on, so this will be 1 over 5. And now add minus 7 plus 12, that is 5. 42 minus 42, 0. Minus 2 plus 2, 0. 12 minus 7, 5. Multiplied by x, y will be equal to 1 over 5. Then subtract 91 minus 66, that is 25. And 26 minus 11, that is 15. So now we can be able now to multiply by the fraction the element of each of the matrix. A fifth times 5, that is 1. A fifth times 0, 0, 0, then 1. xy will be equal to a fifth times 25, that is 5. A fifth times 15, that is 3. Now I want you to notice that this is an identity matrix and therefore it is equal to 1. Therefore we are going to equate the corresponding elements, and therefore x will be equal to 5 and y will be equal to 3. So that's how we use matrix method to solve simultaneous equation. Thank you so much up to that particular point. See you in our next video. Thank you. So thank you so much for watching, and my dear listeners, continue to support me by subscribing, and thank you so much. See you in our next video. Thank you.